14. Right, so we have learned how to actually differentiate logarithm functions already. Okay, so today we will just be looking at certain problem sums, so the same applications, okay, from what we have covered previously. Okay, so for try 14, there is a curve being defined by this equation y equals to ln x, where x is more than 0. Okay, we want to find in part 1 the equation of the tangent at the point where x is equals to 2. So how do we find the equation of the tangent? Okay, so we find the derivative. The derivative will be giving us the gradient at for the tangent, right? So the derivative in this case is 1 over x, and then the gradient of tangent at x equals to 2, that would actually be 1 over 2. Right? Then what next? Okay, we need to find out what is y. So y will be equals to ln 2. Then we can find out what is our equation. X minus 2. Oh, sorry. Just leave it at that. Okay. Part 2, we want to find the coordinates of the point where the tangent cuts the y-axis. Okay, so what do we have to do? So we will just do our sub in what? X equals to 0, right? So when x equals to 0, so the point will be 0, ln 2 minus 1. Greater
or like tangent.
Correct. Okay, so given in question 5, exercise 17.3, we have the equation y equals to ln x plus 1 over x plus 1. We want to find the values of x for which y is an increasing function. Okay? So what do you recommend that we do first? Dy dx. our first derivative will be that. Then what next? Okay, it will have to be more than 0 because it's an increasing function. Okay, then what? How do we find the values of this? How to solve? Huh? Bring it over. Okay, I see that in your homework, right? Okay, that I'm being stopped from returning because I don't have one piece of homework, which I don't know, is it you never submit or I lost it. Okay, so let's stop clarify on that. Okay, I see that this question, okay, many of you, okay, when it came to that topic, you just jump straight to telling me that this is more than 0. Okay, now you cannot actually give times x plus 1 squared on both sides of the inequality. Okay, why is that so? Because x is a variable, okay, so x could be equals to -1, but then of course in this case x is more than -1, but then the whole idea, okay, isn't really about multiplying both sides by a certain variable. Okay, it is because x plus 1 bracket square itself is more than 0. If this thing is more than 0, the numerator has definitely to be more than 0. That's why you will get the inequality. So please be very clear in your explanation. Okay, I want to see this part here. Okay, I will let you know again where your homework went wrong. Okay, or rather all your homeworks are being filled up with that statement. Okay, when you receive it back. Okay, so please make sure that it is clear in terms of your understanding. Okay, so then after at this point here, so what? How do we continue? Huh? Okay, so you can rewrite your inequality in terms of this. E to power 1. Okay, so this is an inequality, right? It might be a bit difficult to actually go about solving this. Okay, you just take note that ln x plus 1, okay, is less than 1. Alright, so okay, when this is equals to 1, okay, you get e to the power 1 equals to x plus 1, right? Wait, yes.
How come since the denominator is more than 0, then the numerator will be 1?
Because if it's less than 0, then it will be multiplied. Then the negative will be less than 0.
No, but then the teacher beside you if the numerator can also be negative 1.
Then, if the numerator negative, the denominator positive, what is it that you have written here?
Then it doesn't go again.
This is what?
With
What is it?
Means
you will do that, right?
Small.
start with letter P. Is a
Positive.
positive. So whole thing must be positive. Down here negative, this one positive.
Negative.
Can
Then
whole
you
thing
go
still be
again.
positive?
Oh.
You
Okay.
write is
Huh?
Okay. Yes. Okay. So wait at this point, okay, we get the inequality. Right now we want to try to solve, okay, for the value of x. Okay. We do not actually in inequalities we do not really actually put in like exponentials and all that. Okay, to discuss it. Right. The reason is because for inequalities we only know that we can plus on both sides, minus on both sides, times on both sides, and divide by both sides. So we do not do things like exponential on both sides or logarithm on both sides. Okay, so let's just go about solving. Okay, ln x plus 1 equals to 1 first. Then we see that e to the power 1 is equals to x plus 1. So therefore x is equals to e to the power of 1 minus 1. So e to the power 1 minus 1. Yes.
less than 1 is
Sorry?
the whole entire function.
I haven't finished yet. Yeah, can you give me the time to finish what I want to say first? Okay, so you solve it first. Okay, so x is equals to e to the power 1 minus 1. Okay, then after that you can tell that in your logarithm function, if you want it to be less than 1, Okay, your x has got to be x got to be less than e to the power 1 minus 1. Okay, so x has to be less than e to the power x has to be less than e minus 1. Okay, for this to happen. Okay, then after that, since x is more than negative 1 given in the question, okay, you can go and compute e to the power 1 minus 1 is actually greater than 1, greater than negative 1. Okay, so therefore this will be the inequality that we get.
X is less than e for e minus.
Sorry, hang on, let me figure this out. X, Y.
Because x is to plus 1. Oh my god.
The reasoning over here, right, if you recall, okay, if you draw the graph for y equals to ln x plus 1, okay, y equals to ln x plus 1 would be this graph over here, okay. If you don't know why, alright, the shape itself, okay, you can go and refer to your chapter 7, alright, the shape will be like that, okay. The intercept over here, right, it is when y is equals to 0, okay, so 0 equals to ln x plus 1. Okay, then after that, e to the power 0 is equals to x plus 1, 1 equals to x plus 1, so x is equals to 0. Okay, so that's how we find the intercept over here, right? Okay, then after that, right, what do you actually want to find in this case? Okay, you want the ln x plus 1 to be lesser than 1. Okay, so to interpret this in a graphical sense, okay, this is the line y equals to 1, right? For this entire thing to be lesser than 1, we're trying to interpret this part over here. Alright? Okay, so we find out when ln x plus 1 is equals to 1, which is at this point over here, okay, what is the corresponding x value? Okay, which we have solved to find that it is e minus 1. Agree? Okay, and then after that, so therefore, for this inequality to happen, which is this section of the graph, okay, you will find that x has to be lesser than e minus 1. That's why we will be getting this part over here. Do you understand what I'm saying? Anybody to understand?
What's it like?
Just tell you.
Why is it that y equals to 1? Because this is 1, right? Okay? Anybody to understand which part? Yeah, Shaolun.
Why must the x be less than e minus?
Because okay, we are trying to find out when your function over here is lesser than 1. Okay? Y equals to 1 is at this point over here. Lesser than 1, it covers all this point over here. The corresponding y values are all lesser than 1. Agree? All these points, they have y values that are lesser than 1. Agree or not? Based on axis. Okay, so therefore, okay, we need to find out what is the x values. We want to find the set of values of x. That is what the question wants. Okay, so therefore, when I solve the equation, okay, I find that x is equals to e minus 1. So therefore, interpreting from my understanding of the graph, okay, therefore I can conclude the inequality will be x less than e minus 1. Okay, yes.
Not x plus 1 less than 2. So
Yes, okay. Yes, so if this were to be lesser than 2, then you consider how to solve when it's equals to 2. Find out what is the inequality, find out according to the range. Then if, for example, if I want ln x plus 1 to be more than 1 instead, also continue to solve, then interpreting from the graph, you will be able to decide that the inequality has to be like that. Do you understand what I'm saying? Yes, okay, because you just want to find out what is this point here. Okay, so we just solve the equation, replace it with equal first, okay, find out what is the intersection point, then after that we can interpret the graph from there. Right? Any questions? Are we clear? Okay. Okay, so if no questions, then let's move on to another one. Okay, question 6, we're looking at crime rates. Okay, the reason why I really want to do this one, going back to this, I don't want you to really go and work on the inequality. It's because some of you might actually do not know where exactly the inequality might face. So I do not want it to actually end up being a routine kind of thing. Okay, where you did memorize that, oh, the E must be here, the E must be there. And then while in the exam you get nervous, you don't know where the E has to be placed. Okay, so the correct understanding is to really rely on the graph. Okay, looking at the intersection, find out what is that value, then after interpret from there. I think that is the correct understanding. Okay, rather than having to memorize the way that the inequality works. Okay, and it may not always work that way. It will not be able to apply for all other functions also. So the understanding there is not right. Okay, going back to question 6. Right, we have the number of crimes seen in a particular country between 2000 and 2010. Okay, was given by this function here. Right, where t is the number of years passed since 2010. Okay, t is after. Okay, we want to show that c is an increasing function. Okay, for this particular inequality. Right? What is the given condition? What do you want your end product to be? Well, okay, tell me what is the end product in order to answer this question. Okay, so the very end, you must prove that dc over dt greater than 0. Okay, this is what you want. What is the things, the information given to you that you can use after that to actually get to this stage? What is the given information? The equation, okay, you are given the equation. Any other things that are given to you that you can use? The inequality t, okay? So therefore, we make use of this to develop this thing, okay? Not the other way around, alright? Okay, why I'm emphasizing on this? Because many of you in your homework, you have it in the other way around, okay? So in this case, we differentiate this first. Okay, we will get 0.1 plus 1 over t plus 1. Okay. Then what next? Okay? Our main objective is to show that this is going to be more than 0. Okay? 0.1 is a positive number. Okay? We will expect that this value over here is positive as well, so that it can be more than 0. If it's going to be negative, then likely your entire expression might go towards negative. Okay? So how do we go about building that? To answer that this part is going to be more than 0. Okay? We will make use of the inequality given to us. Right? So t is between 0 and 10. Then what do we do from here?
Just plus t.
Okay, we get plus 1 because our expression at the denominator is t plus 1, right? So 1 less than equals to t plus 1 less than equals to 10. Okay? Then what next? We want 1 over t plus 1.
So why is it not 11?
Sorry, 11 by 6. Okay? Yes, you can consider reciprocal, but you can clearly tell that t plus 1 is greater than 1 already, right? But less than 11. But regardless of what, it is greater than 1, which also means that it is going to be positive. So, since t plus 1 is more than 0 due to your statement over here, you can tell that it's going to be positive. Okay? 1 over t plus 1, surely it makes logical sense that this is going to be more than 0 as well. Right? Sorry? Okay, you cannot just take reciprocal 1 over 1 and then 1 over t plus 1, 1 over 10. It doesn't make sense already. Okay? Why it doesn't make sense?
Then it will be the other way.
Because 1 over 1, then this is actually 1 what? This is 1 over 11. Okay? 1, how can it be less than 1 over 11? Doesn't make sense, right? So please don't make that kind of mistake. Okay? Okay? Okay, then after that, since 1 over t plus 1 is more than 0, we will then be able to conclude that dc over dt will be more than 0. Okay? So therefore, c is an increasing function. Okay? For this given condition. Okay? Yeah. For what? Why? The x at 11, why does it end at 11? Or 10 plus 1 to be 11. As in, why t plus 1 ends at 11?
No, as in like the c is an increasing function. For only that range.
The question is asking, for that range, how is it an increasing function? It is not asking you, okay, why is it that it must be in this range? You understand? Okay, the question is not asking you why is it that it must be in this range, then it's decreasing function. So your logical sense is not right. Okay, if you think that way, then you will be going in this direction. Let me clean this whiteboard first. Okay, if you think about it in that way, then your proof will be dc over dt more than 0. Okay, 0.1 plus t, 1 plus t plus 1 over t plus 1 more than 0. Okay, then you will start to go into this direction, then that's not right already. Okay, that is not the intention of the question. The intention of the question asks you to prove that it's increasing function given this particular information. Okay, not the other way around. Alright? Okay, one last question before we end off this chapter. already, right?
Yeah.
Okay. 8a, right? We want to show that this given equation for the given condition x more than half has no stationary points. So what is the final thing that you need? How do we show that it has? What is it that we need to show? Okay, dy over dx, right, not equals to 0 because there's no stationary points. No stationary points means that your derivative is not equals to 0. Okay, not equals to 0 could actually mean that maybe it is more than 0, less than 0. Okay, it could be either of these two cases, or if it could clearly be just not equals to 0. Okay, so that is the end thing that we need to show. Alright, we are given two pieces of information. One is the equation, another one is the inequality. That within this particular interval of x values, there are no turning points, no point of inflection. Okay, so we will look at the derivative. So dy over dx so that will be dy over dx equals to 2 over 2x minus 1. Okay. So now we make use of the next given information. For x more than half, what exactly will happen? What is it that I want? What do I want to manipulate? How do I want to manipulate x more than half?
X more than
I want to reach the 2x minus 1, right? So I times 2. 2x is more than 1. And then after that, minus 1 on both sides. I see that 2x minus 1 is going to be more than 0. So if 2x minus 1 is more than 0, okay, and 2 divided by a number that is more than 0, regardless of what, okay, dy over dx will have to be more than 0. Okay? It can only be more than 0, yeah? Positive denominator, positive numerator. The entire fraction will be positive. So hence, y equals to ln 2x minus 1. There's no stationary points. For x more than half. Okay, any questions? If not, then homework. Yeah. What? Oh, thank you, sir. Exercise 17.3, question 7, 9, 11, 13. Would it be due on Friday? Okay. Okay, so tomorrow we will have our maths test, right, remember? Okay, I will put up the marking scheme for 2017.